Good morning to one and all. So in this session we'll discuss about additive manufacturing concept. The aim of the session is to familiarize the students with the basic concepts of additive manufacturing process, and the objectives are: the session is designed to understand the concept of additive manufacturing, to understand the systematics of manufacturing technologies, and to describe about the rapid prototyping wheel. The learning outcomes to be expected at the end of the session from the students will be: the session is designed to define or to get the definition of the additive manufacturing at the end from the students, and also they can able to summarize the advantages and disadvantages of additive manufacturing process, and also they can able to classify various additive manufacturing technologies also. So first I'll start with the definition of additive manufacturing. It is a process of joining materials to make 3D objects from three-dimensional model data. Whatever the 3D drawings are available in a CAD software, that we can convert into STL format. By loading that particular format into a 3D printing machine, we can able to print that existing 3D model as it is. How we are printing? Layer by layer we are going to print, and we can able to get that particular 3D object, a live object. We can able to visualize that. Whatever the corrections we can do, that we can do on the existing design after observing this particular 3D object or prototype available with you. So simply, this additive manufacturing is one of the process of joining materials to make 3D objects from the 3D model data. Next we'll go to systematics of manufacturing technologies. So based on the geometry orientation, the manufacturing technology process is generally divided into three different types of fundamental clusters. The one is subtractive manufacturing technology. You can able to see subtractive manufacturing technology here. Subtractive means, you see here, the final shape of the part is going to be obtained by removing the excess or unwanted material from the parts. We are removing the excessive material, which means we are subtracting a material from the original one. That's why this technology name is a subtractive manufacturing technology. In this process, the desired objects can able to produce after removing or subtracting the unwanted material or unwanted portions. The examples are: you take a turning process. In turning process, to get the required shape, that may be profile turning or step turning or taper turning, after removing the excess material with the help of the tool only we can able to get that. That is the best example for the subtractive manufacturing technology. The next one is formative manufacturing technology. Formative, you see here, formative. In formative, what we'll do, without removing or subtracting the material, by forming process, which means by doing the shaping only, we are going to change the size or dimensions of a part. How? By keeping the part in between the two dies, by applying a force with the help of a deformation process, that part is going to be expanded as per the shape of the die. The examples which will come under this formative manufacturing technology are: you take a bending process, you take forging process, rolling process. Here we are just shaping, by applying some external force, we are just shaping the given part, so that the shape of the object is going to be changed as per the applied load, so that without removing or without adding the material, within the same material we are changing the shape. That is called formative manufacturing technology. As I told you, the rolling process, the bending process, extrusion process are all examples for this formative. And lastly, additive manufacturing technology or additive manufacturing process. Additive is different if we compare it with the subtractive or formative. Additive manufacturing is nothing but we are adding material layer by layer to get a desired object. We are just adding material. So based on the existing 3D CAD design, as per that, either with the help of any existing 3D printer or 3D printing technology, by printing the part layer by layer, we are adding material so that the desired part is going to be obtained. So that we'll do in the additive manufacturing technology. The best example is 3D printing process only. Like that, the manufacturing technology is generally divided into 3 different clusters. Those 3 we discussed so far. Next, the rapid prototyping wheel. So this rapid prototyping wheel depicts the 4 major aspects of this additive manufacturing technology or the rapid prototyping technology. The first one is input. What type of input we are giving to this particular RP system? Generally, from the CAD model, whatever the model we have created in a CAD software, the same if you want to print, so that we can give it as an input to the rapid prototyping or an additive manufacturing machine, for which you have to save that particular file which you created in the CAD in the format of either STL or IGES or CLI, etc. There are different formats are available. If you save the file in that format only will support the RP machine to accept that, to verify that later only it will print that particular component. Okay, so like this we'll give the input. Next, material. In rapid prototyping machines, we have liquid based machines, powder based machines, different machines are available. Okay, the raw material which you are giving to the RP machine, that we can give in the form of a liquid, in the form of a powder, or in the form of a laminates or wires also, etc. Okay, the papers, resins, nylon, ABS, wax, metals, different materials, PLA, PETG, these are all various materials we can use, through which we can print various components with the help of rapid prototyping machine. The next one, method. What type of methods we are using in the rapid prototyping? We can go for photo curing operation, or cutting and gluing operation, melting and solidifying operation, or joining operation, or binding operation. We can use the help of the laser beam. Okay, we can use 2 laser beams, we can use mask lamp. There are different methods are available. By using any one of these existing methods, we can able to print the components using rapid prototyping machine. Lastly, applications. Where we'll use this rapid prototyping concept? In aerospace applications. In aerospace, you take any component under aerospace application where all the parts are very costly. So before manufacturing those parts directly, the new components, first we'll print it, later we'll observe it physically. Whatever changes we can do, we can able to perform various analysis. Then only whenever the component is ready, then only we'll go for the real manufacturing. Not only in airspace, in automotive applications, in biomedical applications, in consumer product industries, all wherever the designs are complex, those designs definitely first we have to create in the CAD software, then we have to print it in the 3D printing machine, then only we will go for the further action. Okay, in such way, in all these applications we can able to use this rapid prototyping technology. Coming to the advantages of additive manufacturing, we'll go for the first one, rapid prototyping. Rapid means fast. Okay, whatever the prototype you want to print, very quickly, very efficiently we can able to produce with the help of this additive manufacturing. Improved accuracy. Whatever the parts you are printing from the rapid prototyping technology or additive manufacturing process, for the final parts, the 3D printed components, the accuracy is very good. With a very much improved accuracy, we are going to get the components. and the wastage is going to be very less here. Okay, if you take a normal conventional machine, there if you want to shape a particular part, if you want to remove the unwanted material, lot of wastage we are going to get. But since here we are printing a part layer by layer, the material wastage will be very less in the additive manufacturing process. And also ability to consolidate assemblies also into single part. Okay, generally in a part sometimes different assemblies means it's a combination of 2 to 3 parts are also available. But if you want to print the entire assembly as a single part, yes, it is possible only with the additive manufacturing concept. There, by loading the entire assembly as a single geometry, as per that only that machine will print that assembly as a single part. That ability is also existing with the additive manufacturing technology. And also this can improve the existing part properties also. Okay, by minimizing all the errors, definitely the part properties are going to be improved. And with this additive manufacturing technology, we can able to create very lightweight parts, okay, with which we can able to perform the further analysis very easily, we can able to carry very easily. And the inventory reduction, we no need to maintain so much of inventory. The cost of inventory is also going to be reduced with this. And whatever the parts we are producing from this additive manufacturing concept, whatever the parts we are printing, those are all environmentally friendly parts. These parts will not do or will not do any harm to the environment and also to the existing human beings. So these are all various advantages we can able to get from the additive manufacturing concept. Coming to the disadvantages, yes, definitely there is a dark side also for the additive manufacturing along with the benefits. Let us see. The first drawback is initial startup cost. The initial startup cost is very high because since it is a modernized advanced technology machine, the initial cost is very high to start up a process. Next, the high cost of entry. The cost of entry is very good and also very high. The cost of entry is very high. The cost of installation is very high. Whenever any repair occurs, the cost of maintenance is also very high. And also the production cost is also very high since it is a costliest process. Even though we are producing a lightweight parts, economically friendly parts, okay, and we can able to generate the parts quickly, all benefits we are getting, but the cost of production is going to be very high for that. Okay, and it can be a slow. Sometimes the printing process, when compared with some other existing processes, this process will be little bit slow. Okay, when compared with the other processes. Limit on materials. All materials we can't use for this additive manufacturing. As I mentioned, ABS, PLA, PETG, paper, there are some specific materials only, the light materials with which we can able to work on this particular additive manufacturing concept. We can't use all hard materials. There is a limitation on this. Even though the metals also we can use nowadays to print, but there is a limitation. Post processing requirements are there, means once the part is completed, later it needs some other post processing steps required to deliver it to the customer. Such post processing requirements are there. So these are all various disadvantages identified from the additive manufacturing process. And here I am giving a classification of additive manufacturing. We have solid based systems, powder based systems and liquid based systems. Let us see. I am classifying the additive manufacturing into three different solid based is the one, powder based is another one, liquid based another one. So based on the physical state of the raw material, additive manufacturing concept is being classified into these three types: solid based, powder based and liquid based. Based on a manner in which the material is fused or deposited layer by layer, as per that, under this solid based system we have fused deposition molding FDM process is there, electron beam fabrication process is there, and wire arc additive manufacturing process is also there. Okay, all these will come under solid based systems. Under powder based systems, you can see we have SLS, selective laser sintering process, electron beam melting process, selective laser melting process, and a fused metal deposition process. All these processes will come under powder based. Coming to the liquid based process, we have SLA, which is one of the important and famous process, stereo lithography process, and also direct light processing process, DLP. These are all various technologies. Okay, by using all these, we can able to create 3D components. So depending upon the geometry, depending upon the requirement, depending upon the type of the metal used, we can able to choose any particular operation or any particular equipment or setup to produce desired components. That may be solid based, or that may be powder based, or that may be liquid based. So the activities or case studies mapped to this session. So designing for additive manufacturing. A hands-on activity guides you the process of creating 3D models tailored for additive manufacturing. And coming to one of the case studies, just I'm suggesting this case study, aerospace industry implementation, exploring how additive manufacturing is transforming aircraft component manufacturing. That you can also consider as a practice or a case study. And coming to the examples, I'm giving some specific examples here. Medical innovations, prosthetics, implants, some custom medical devices produced using additive manufacturing techniques. Generally, the prosthetics are very costly things. Those implants, okay, so many medical devices nowadays. We are printing all those things into with the help of 3D printing processes only. Even sometimes you see in the dental hospital, you can able to observe. Okay, so our teeth or the complete set, all we can able to create with the help of additive manufacturing technology. Only the same sets after testing are being used. And also in the sustainable manufacturing, the case study is highlighting how the additive manufacturing reduces the waste in the production processes. Economical, environmentally friendly parts only we are producing through this, which leads to sustainable manufacturing only. These are all examples. And coming to the summary in this session, so far you have learnt about the importance of additive manufacturing and the advantages and drawbacks of additive manufacturing techniques. We discussed about the classification also in detail. And the self-assessment questions, what is the another term commonly used to describe additive manufacturing, which is nothing but 3D printing. Which of the following is not a common additive manufacturing process? CNC machining is not a additive manufacturing process. Here you see FDM, SLS, SLA, these are all will come under various additive manufacturing process, but not the CNC machining, which is a different one. And these are some of the terminal questions mapped to this particular session. These are various books you can refer related to this session. Thank you very much.